Hello, everyone. My name is Yuri, and today we will talk about support of C++ programmers. But first, a couple of words about myself. I am a C++ developer at PVS-Studio. It's a company which makes a static analysis tool for C++, C#, and Java. But enough about that. It's not what this talk is about. So what is this actually about? Well, there is a joke when a guy comes to a doctor and asks, "Doctor, am I going to live?" And the doctor says, "And what's the point?" So there needs to be a point, doesn't it? So let's take a look on that. So we will talk about technical support, like I said, but not just any technical support. It's specific support for people who are also professional C++ developers. And I'll cover just a couple of funny cases we've got while working with our customers. Yeah, and you know, usually those talks about C++ are serious, but we'll just drop a little bit of humor there. So about tech support, that's what it looks like usually. And why is that? Well, because we have to deal with some obscure pieces of code. That's our specific. And why am I going to talk about it at all? Well, there are a couple of reasons. Programmers typically know what they want, and it's usually interesting to work with them because they are kind of, they are smart this way. They not only know what they usually want, but they can sometimes understand what the actual problem is and suggest maybe even some solution. And yes, they are smart people, so it's a pleasure to talk to a smart person. But first, let's ask a question: why do people go to tech support at all? Well, because they have a problem, right? And what do we have to get rid of problems? Well, testing. So we test a lot, and we have various types of tests, and it's a lot. It's so much testing that it looks kind of like this when you're actually done with them. So there are literally 9 circles of testing, and let's see what they are. We have documentation tests, because our documentation contains code examples which trigger certain warnings. So we need to make sure those examples actually do what they are supposed to do. We have UI tests for UI parts of our product, and we have your average good old unit tests, you know. We have tests for specific diagnostic rules, which are similar to unit tests, but not exactly. And we have a huge collection of real projects, and we run our analysis against them to make sure no changes we make break anything. We have, of course, dynamic analysis. That's basically runtime code instrumentation and runtime checks for memory leaks and stuff like that. We use our own static analyzer to check our own code, and sometimes it also finds funny things. We have a compilation monitor system, which tracks compiler launches in the system, and we also test that. And of course, since we are making a cross-platform application, we use Docker to test on different distros of Linux and other systems. So yes, that's a lot of testing. But still, even with that, uh, people are very inventive and many bugs slip through, which we don't even think about. So now I will tell you about some of them, some interesting stuff we've got. So it's story time, yay. Okay, about standard functions from the standard library. Let's take a look at that small code example. Well, as you can see, nothing much is going on here. There is a buffer, and some kind of value is parsed from integer and put there, and the buffer is used somewhere along the execution graph to do something with it. Pretty standard. And what does the analyzer say? Well, it thinks that the buffer is not initialized. How is that possible? I'm pretty sure Sprint does its thing perfectly, at least it did last time I checked. Yeah, like right here, the buffer is clearly initialized in the Sprint call. So it's impossible. It must be a bug in the diagnostic, right? Well, maybe. Maybe it's an actual bug, but you need to agree it's really obscure and strange. So what's going on here? Let's take a look on what's actually going on in this example. When we started debugging it, we found an interesting piece of code in one of the headers. So as you can see here, Sprint is not actually Sprint. It's a macro definition which substitutes Sprint calls with print. And that code we've seen earlier, it's actually dangerous because you're passing an empty string into print as the first parameter. Yeah, things like that sometimes happen, and I'm curious what the person who did this thought. Anyway, let's move on. Let's go to the next one. And it will be more on standard functions because they are awesome, aren't they? So yeah, here we have, again, quite a small and quite standard, I would say, piece of code. What it does, it is supposed to go through all the characters in a file, in a string which is read from a file, and it skips all the white space characters except new lines. So, well, looks good to me. Let's see what the analyzer says. So C doesn't equal new line is always true. Well, again, I think it's a bug. It seems like this is an incorrect diagnostic message. And we need to debug it and fix it. And you know, last time I checked, tests were working on that, so it's really weird. Well, maybe I'm wrong on that. Maybe isSpace does something strange, but if we look at the CPP reference website, a documentation about isSpace, you can see there that new line is considered to be a white space character, so space won't actually return false on encountering new line. So that cannot be, the message we get cannot be real, right? It must be a bug. Okay, so let's take a look at what's going on here. And what's going on in this particular case is, well, it's similar to what was going on in the previous case, because isSpace was a macro. And that's why macros are evil. especially when you name them as standard functions. If you take a look at this code, you see the isSpace macro is defined to two checks. It will return true only if our C variable is either a white space or a tab. So below that, there is the expansion of this macro. This is taken from the preprocessed file, and that's what's going on there. So obviously, if your character is either a white space or a tab, it cannot be a new line. So turns out the message was right. Let me just highlight it for you again, just a little bit. That picture on the left is actually, it was my reaction when I saw it. Yeah. So don't trust standard functions, even if you see them in your code. Sometimes they're not what you think they are. So, oh, and next, I want to talk about the preprocessor. You know, everyone who has something to do with C or C++ knows what the preprocessor is. And it's very important for us because the way that the analyzer works, it makes the compiler preprocess the source file and expand all macro definitions and substitute all includes. And after it does that, it creates a special file which has the extension of I. And this file is what the analyzer uses because it's more convenient that way. We don't necessarily want or need to implement our own logic for macro and include expansions. So the preprocessor is important, but even it sometimes can behave in a weird way. So let's take a look at this code. It says something strange, doesn't it? So there is a line directive which maps this specific source line to another file. As far as I know, it's used to trick the debugger in some ways, but it's not important here. What's important is that the message we get, if you look down below at the picture, you will see that the message complains about this somefile.abc thing. And obviously, this file doesn't exist. Well, division by 0 is, yes, it's just a synthetic function to show you what's going on. So the message is correct, but the location of the error is wrong here. So let's take a look at the reason why is that. Why is that, really? Well, to answer this question of this doggo, we need to take a look at what the output of the preprocessor is. So this is going to be a preprocessed file. That's from Visual Studio. So it goes like this. First line is demo source, then function definition. So here we have it. So after doing its thing, the preprocessor leaves this line directive intact. And what happens next when the analyzer goes through the file? It uses those line marks to determine location in the source because this file, this one is small, but in general, it will be large. It will include code from all the headers, and it will have those marks indicating where each file starts and where the code actually comes from. So in this case, it's not strictly a bug, but some people do that sometimes, and it causes pain. But good news is that we can detect that and warn you. So we won't fix the root cause of the wrong warning location, but will warn you that you have your line directive in your code, and you might want to comment them out to before you do analysis. Yeah, so it looks like this, and it's much better. So now we'll just tell you that you have line directives, which you're not supposed to have. Okay, moving on. So let's assume, just pretend, okay, that you have a huge, well, not a huge, but quite a large memory space allocated, and you want to somehow initialize it and fill it with some values. So what do you think? Will a hard-coded constant in your code work? Just don't do any runtime, dynamic, memory filling. Just put a big constant in your code. Will it work? Well, I mean, apparently it's possible to do so, but the results may vary. So what you see here is it's literally 26 megabytes of the letter X. It was from source code, and the problem was that when analysis ran on this, it stopped on timeout. So yeah, it kind of looks like a bug, but just as a side note, this is a screenshot from Notepad++. And my Notepad++, when it saw this file, it hanged. It decided that, no, I won't do it. So even if I remove line wrapping and highlighting, it still hangs. Not fatally, but becomes very unresponsive. And even if a text editor doesn't want to deal with that, imagine what the application which actually does meaningful with code will feel about that. So it will feel badly. This is a screenshot from Visual Studio after I launched analysis on that file under the debugger. So in debug mode, we consumed, what's that, 11 gigabytes of memory. And after the analyzer did this, this happened. So it was hanging completely. That was a bug. It's fixed now. Now we can chew code like that, but don't do that, please. Okay. Yeah, what programming is all about? It's about logic or logics, right? So let's take a look at some funny logic examples. So what you see here is, it's quite a simple check, right? So we'll just have like a million operations here, but it's all good, it should work. Except it doesn't, because what we get is 4 warnings which talk about some weird stuff. They say that the part of conditional expression is either always true or false, and they complain about those for the last 4 expressions in this code. And this example was very challenging for some people on our team. Of course, we figured it out, but it wasn't easy. What was making it more difficult is that here, those checks are on separate lines, but in the original source file, they were at the same line. And it was a nightmare to even try to read that. So let's check why would we complain about true or false conditions. So here, what just happens, there are checks of 3 ranges of values. And if our variable falls into none of those ranges, the if is supposed to fire. So yeah. This code, I won't say it's necessarily really bad, but it kind of smells. So if you have conditions like that, you may want to reconsider your logic. So that highlighting is the real cause of the problem. So as you see here, the intent was to check that the value doesn't fall into any of the ranges. Instead, what it does, it applies the logical not operator to the first one. They forgot a brace here, a bracket. So what we have here is if the value gets into the first range, this not operator will make this part of condition false. So the entire condition will never become true because our value will not fall into 2 other ranges, obviously. And on the other hand, if the value doesn't fall into the first range, this expression becomes true. And then the short circuit logic disables further checks. So yeah, this if will never properly work. Yeah, that's much better, right? I think it's much better. Okay, let's move on. Yes, initialization. Well, as you might know, C++ has a couple of ways to initialize things, a couple million ways, more like, but let's take a look at this class. So it's kind of some kind of a vector in mathematical sense. It has its coordinates, x, y, z, and in the constructor, 2 fields are initialized, and the third one is omitted. And that was not a bug, really. It was a request for one of our customers. The request was to make a diagnostic rule that would find such cases in source code. And it will catch uninitialized class members. Now it's easy, right? So what can be difficult here? We just go through all the members. We check that all of them are used and initialized in the constructor, and that will be it, right? So that's easy. So we just did it, and it worked perfectly, and that's the end of it. Not really. Let's see what you can do to mess up with initialization. You can do that. So you don't necessarily have to initialize anything in the body of the constructor, but that's also easy because that's just the initialization list of the class. We can easily go through it and check that everything is okay, but you can also do that. So here, if we do our constructor analysis, we won't see anything because those class members have default initializers. And that's not a big deal, really, because yeah, we know the collection of fields, and we know even which fields are inherited from the parent. So it's not a big deal. It's easy. Well, you can do a default constructor, kind of like the previous case, except you just need to account for that. So still easy, kind of. Uh, yeah, you can do a function which will initialize your values and call it from the constructor. Gets a little bit complicated, right? A little bit, because in this case, you would need to recursively check all the function calls, and that can be painful depending on circumstance. But there are other ways you could do your initialization. So let's take a look at that. Here, someone decided to use memset to initialize one field in the class. And in this case, it's just one field. But imagine if we took that size of there and just multiplied it by 3, we would cover the entire class. Or we could pass this pointer into the memset call, and that would work until you meet your first virtual function in the vtable there. And believe it or not, there is a placement new operator, and it also can be used to initialize your class instance. And it can work, but it was a pain to implement this kind of diagnostic rule. You know, there is this exponential growth of complexity. Sometimes the task which looked easy in the beginning turned out to be quite a challenge, shall I say. Okay, the next one. That one is a good one. So what you see there is what the excuse we usually give to people who ask, why is your code analysis better than code review? Well, it's not really an excuse. It's kind of true, because code analysis is like a code review process, but automatic code review process, and it's cheap because you don't use your expensive developer time to do code review. The analyzer has infinite attention span. It doesn't get tired, unlike humans, who after 5 minutes start to skip over obvious errors. And there are some error patterns in code which humans sometimes don't know about. Even experienced developers sometimes skip them. So all those three are kind of true, but kind of not. This one, turns out it's not always true. So the analyzers can get tired. Here, this is a screenshot from Visual Studio again. And it's a single file with a single function, and it's all in main. Just let me give you the idea of how huge this file is. Yes, that's the number of the last line. So it has almost 1 million lines of code in one single function. And why this is bad? That's because the analyzer goes function by function. And while it goes through every specific function, it saves a lot of data. It needs to check which execution paths work and which don't. It has the data flow mechanism, which saves values for all variables inside this context and this scope, and plus global ones. And analyzing one function, if it grows huge, can be a problem, because you can run out of memory, it can be very slow, and so on. if you have a lot of smaller functions, that's fine because all the buffers get cleared between them. Yes, it's not a surprise that a function with a million lines of code was a little bit tiresome. So that's what the analyzer looked like. It worked, I think, for like 10 hours. And it consumed all the memory it could have consumed because of that data flow mechanism, and eventually it just died. Okay, so that was kind of a sad story. Let's go to something funny. If you are a real hero, you might want to wander around the land, saving people from monsters and so on. So you don't necessarily want to go to your destination directly. That's what happened in this next case. But first, let's take a look at that. So that's the division by zero thing from earlier. And you see there, it's a header, and the error comes from this header, and the header actually looks weird. It doesn't have include guards and doesn't have any definitions, really. It just has one line of code, and why would you do that? Well, because you want to be weird, maybe sometimes. So that's the code from which it came, and that looks kind of crazy, to be honest. And that example is synthetic. It's not from a real project. That's what I made up. But that one is from a real project. And you see here a switch, which has an include there. And that file, which gets included inside the switch, it has all those cases. It's a huge file with cases. Of course, it's not a problem by itself. Just a weird thing to do, I think. But who am I to judge, right? Let's move on. Do you like Windows API as I like it, as I love it? Well, you should, because it's awesome, right? It's not, but yes, it's awesome. So if anyone used Wine at any point, you know what I'm talking about. Wine, for all those two of you who don't know, Wine is a Linux application which allows you to run Windows applications under Linux. And it has its own emulation of Windows API and all the DLLs. And what's funny about it, it allows you to actually choose what version of a specific DLL you want to use. You can use this implementation or that implementation or the other implementation, or you can use the native DLL taken from Windows. And why is that? Let's take a look. So here is a Windows API call to a function which does some security stuff. And it has some of the parameters which actually return values. So it has out parameters, and that's typical for Windows API. And if you take a look at that, we have a pointer to a structure. We pass it to the function, and then we test it against null. Everything looks right here. It will be initialized there. But the analyzer thinks that this pointer is always null. So this check will never be false. So how is that? Maybe it's a bug in the function or in the diagnostics, or it's just weird, right? So let's check the code. Yeah, it's initialized, of course, with null, as you would probably usually do. It's passed to the function by a reference, which is a non-constant reference, mind you. So it will be overwritten, or rather, it may be overwritten, but the analyzer knows about that. And then it checked, and it still cannot be null. Maybe I'm not getting something here. Let's go to MSDN and check. The highlighted parameter, that's what we are interested in. So as you can see, no const there. It's passed there by pointer, so we can modify it inside, and the analyzer again knows that. So what's going on here? And that was the question we asked when tried to debug this issue. And the funny thing was that while debugging it, we couldn't reproduce this behavior. So it always worked perfectly. We never got the warning. Weird, isn't it? So we decided to ask the user to send us the preprocessed file, and what we saw there and blew our minds a little bit. And what we saw there in the preprocessed file was that. Yeah, the MSDN documentation says that those parameters are not const, but as you can see here, they are const. They're marked as const. And it turned out that in different versions of Windows, in different Win API implementations, this signature was different. In one specific Windows API version from one specific Windows SDK version under Windows 7, I believe, those parameters were marked as const. So it never worked really. What was supposed to work there, because the function could not modify any of those values because of that. Yeah, so Win API is actually fun. And the last one we've done with Win API, I hope for good at this point, but yeah. The next one is, suppose you want to check your project in Visual Studio, and you go to the menu and you click all those good things there, and you get this window which does something supposedly, and maybe it does something for long, and then as you want to look at the result of the analysis, you see this. That's a big, big problem which affected many, many users. It was the scariest bug ever. Yeah, but really no, because those buttons at the top where it says high, medium, low, fails, and so on, they all are not checked. So some people ran into this, and believe it or not, I myself ran into this a couple of times when you start the analysis and you get an empty results in the end, and then you try to figure out what's going on, and then you go like, yeah, right. They're all disabled, and maybe some files are ignored. Well, fortunately, it's no longer a problem because the scariest bug of the history and century is fixed. Now we will just tell you that everything is filtered out, and you might want to set up your filter. And that would be it about the stories on customer support. And it's summary time, and that's awesome, right? Because the picture says it all about my ability to write summaries, but let's write. So yeah, tests are awesome. If you don't have tests, I don't believe your code. But even if you have tests, humans can still find inventive and creative ways to go around your thorough testing. And don't get me wrong, our users are awesome. We love them. We always want to help them, but at some point, after seeing a lot of interesting and wonderful things, you just want to say, don't take on support of C++ programmers, because they will play games with your mind and your code because they are just so inventive. So thank you very much. That's all, folks.